In this video, we're going to look at classifying triangles as obtuse, right, or acute using the Pythagorean theorem. So the question asks, if two sides of an obtuse triangle are 6 and 12, what is the range of possible lengths for the third side? Well, the relevant theorems for this problem are the triangle inequality, which states that A plus B must always be greater than C. So for something to be a triangle, then the two shorter legs always have to add up to be greater than the longest leg. And then the other is a version of the Pythagorean theorem that says if the sum of the squares of the two short legs is less than the square of the long leg, then it is an obtuse triangle. So we start here, and let's say that the third side of this is going to be x. Now, we don't know what the longest side is. It could be x, or it could be 12. We do know that it can't be 6. So we need to do two cases. Case 1 says that x is the longest side. Well, that means that 6 plus 12 has to be greater than x, based on this one, if x is the longest side. And it also means that 6 squared plus 12 squared has to be less than x squared. So solving these out, this gives us that we know x is going to be less than 18. This one, you're going to get 180 when you do 36 plus 144. And that's got to be less than x squared. So when I take the square root of both sides, I find out that x has to be greater than, well, the square root of 180 is the same as 6 root 5. So x has to be greater than 6 root 5. And so it turns out that if x is greater than 6 root 5 and less than 18, then we would be talking about an obtuse triangle. If it was greater than 18, then it wouldn't be a triangle at all, so we couldn't classify it. And then we do the same thing, except this time we let x be the 12 be the longest side, so x be one of the two short sides. So that would give you 6 plus x has to be greater than 12 by the triangle inequality. So x is greater than 6. So we know x has to be greater than 6 to be a possible length of the third side. And then the same thing as before, 6 squared plus x squared has to be greater than 12 squared. And so that means x squared has to be greater than, well, 144 minus 36 is 108. And so that means x is greater than 6 root 3. So in doing this, we now realize that x has to be between 6 and 6 root 3 and 6 root 5 and 18. And so the correct answer to this problem is this third side has to be either between 6 and 6 root 3 or between 6 root 5 and 18. Now, one thing to notice is the only thing difference between this and the Pythagorean theorem is the equal sign. So if we had equals, then the Pythagorean theorem would tell us that x is 6 root 5 in that case. And the same thing over here is 6 root 3. And so it turns out that the 6 root 3 and the 6 root 5 are when the value for x when to make the triangle a right triangle. And so we can actually create a continuum that says 6, that is the lowest the third side can be. 18, that's the highest the third side can be. At 6 root 3, we have a right triangle. And at 6 root 5, we have a right triangle. And so we know that it is right at that point and that point. And then it turns out, if you make this continuum, that if it's between the two on the left or the two on the right, that's when it's obtuse. And so that means that what's left in between is when it's acute. And so this picture will always work for you to being able to determine what values for this third side tell us if it's going to be an acute triangle or an obtuse triangle. So using that method to do this one, we realize, okay, so I've got 4 and 5. So we're going to have 4, 5, and x. We're doing it as an acute triangle this time instead of an obtuse triangle. So we know that if x is the long side, 4 plus 5 has to be greater than x. And we know that 4 squared plus 5 squared is, and so in this case, it's got to be greater than x squared, though we could just think about it as equal. And so that gives me x has to be less than 9. And x has to be less than the square root of, well, 4 squared plus 5 squared is 41. And so the 41. So we know that If x is the longest side, it has to be less than 9, and we also know that it has to be less than 41. And so when we're looking at our continuum, that's the largest x could be. And then at square root of 41, that's when it's a right angle. Well, now we do it when x is one of the shorter sides. So 4 plus x has to be greater than 5. So x has to be greater than 1. So the other side of our continuum is over here. We know that third side now has to be between 1 and 9. And then we do the Pythagorean theorem, and we get this. We know that the two short sides have to be squared, have to be greater than the long side to be a right triangle. This actually just gives us a Pythagorean triple, right? Which is x has to be greater than 3. And based on what I told you up here, the acute part is the one that's in between, which is what our inequalities turned out, right? X has to be greater than 3, less than 41. And so that's where it's acute. Notice the 1 and the 9 didn't actually end up mattering in this problem because it had to be in between those two right angle values in the middle. So the correct answer to this one is 3 is less than x is less than square root of 41. And so that's a good way to go through and think through these problems is to use this continuum to get your answer.